Okay, welcome to video 2. Here we're going to talk about the explicit formula for the arithmetic sequence. So the arithmetic sequence formula is written like this: a sub n equals a sub 1 plus n minus 1 times d. This is given to you, so you don't have to memorize it, you just have to be familiar with it. So to write and use this rule to find any nth term, you must know the first term, a sub 1, and what the common difference d is. Then you can sub those things in. So a sub n is, just remember our fancy way of saying like f of x equals. And then a sub 1, we need to be able to fill that in with the first term. And then we fill in the d with a common difference. And then we'll still see we have a variable n, which makes sense. We can put things in for n and get out the value. It's similar to the linear function equation that we had before. I just rewrote it with the letters so they were corresponding with these letters that are used. A of n is just like that, a sub n. D is your common difference, which we usually have with the slope, but the difference here is the b term. This is going to be your y-intercept. So the difference between this one is that it uses a first term. This one uses a y-intercept. That's the big difference between the two. Otherwise, they are similar, and we can simplify the arithmetic sequence formula to look like a linear equation. So just make sure that you write that down. The difference is that we're going to use the y-intercept instead of the first term. So when we're using an explicit formula, any term in the sequence can be found immediately just by inputting the term number. So let's try an example. So the first one we have here, if a sub n equals negative 4n plus 5, find the first 4 terms of the sequence. Well, that just means I'm going to do a sub 1. So when we look here, we just sub in that a sub 1 equals negative 4 times 1 plus 5, and when we simplify that, we get a sub 1 equals 1. Now I can do the exact same thing for a sub 2. So all I did was rewrite a sub 2 instead of a sub 1 equals negative 4, where I put a 1 originally in place of n. Now I'll put the 2 plus 5, which simplifies to be negative 3. Now I can do the same thing with 3. When we do that, we get a sub 3 equals negative 4 times 3 plus 5, which becomes a sub 3 equals negative 7. And the last one, we got to do the fourth term, so same thing with the 4. And when I do that, I put in the 4 everywhere I saw an n, and then I get our answers. So they look a lot like our linear equations that we've used in the past. So we have where we take in the n's and then we get out what the value is. So what type of sequence is this? It's linear because there's a common difference. If I look at the pattern, I'll just write them out so that we see the terms. So when I write them out, we can see that we have these terms going from 1 to negative 3 to negative 7 to negative 11. We can see that to get from 1 to the next, we're subtracting 4. So the sequence is arithmetic because this is a common difference of negative 4, or d equals negative 4. Next example, we need to write a formula a sub n for each of the following sequences. So when I look at the first one, we have to figure out what the pattern is so I can figure out if it's a common difference. When I look to get from 2 to 6 to 10 to 14, the pattern there is to add 4 every time, so I know that there's a common difference. So now we can use, since this is a sequence, I'm going to use the arithmetic equation that we have up top, which is a sub n equals a sub 1, which is the first term, which I see is 2, so I'll put a 2 in. And then I just subbed in the n minus 1 stays, and then the common difference goes in for d, so 4. We can put it in parentheses if you'd like as well, just showing that this is going to be multiplied to both of these things. And now I'm going to show you how that corresponds with the linear equation. If I go ahead and simplify this, like I talked about, we can change it so that it looks just like our linear equation. So when I distribute the 4 to both things inside, then I end up with Then I have the a sub n equals 2 plus 4n minus 4, combine like terms, and then we end up with the equation a sub n equals 4n minus 2. Both of these are acceptable answers, and they just look a little different depending on if you're using the simplifying it to make it look like linear, or if you just leave it with the arithmetic equation.